Good. Hi, welcome. Are you alive? Hi, welcome. Okay, let's try this. How many of you are building browser-based UIs? Okay, how many of you are using regular JavaScript for that? I don't believe you. And how many of you are using binary JavaScript? It's called WebAssembly. A couple of you as well, okay? So to be, full disclosure, I don't care about UIs at all. I never had the urge to write a user interface. I was always a server guy, where the world is so much, easier and peaceful than in the browser. But we have customers, of course, which are doing these types of applications. And for the last, 10 years, we helped them building these types of applications. And, I really felt bad for them because so many times, the guidance has changed from do this and do not do this. And then it was the opposite around. Like you have to do this, but don't do this anymore, right? As I said, many times the things have changed. And I really hope we are now at a point where kind of like we find a good middle ground of how to build these applications, both from a UX point of view and from a security point of view. And of course, I only care about the security part. But still, we need to satisfy both. Yeah. So my name is Dominick. I do security for a living. And if you want to contact me, here are my contact details, and there's also the slides. The slides of today's talk are also uploaded to speaker deck. So if you want to have them, just grab them from there. Good. So what's our agenda? I basically want to go back in time a little bit, and look at some history, how we build browser-based applications, and depending, and that might, having a look how things have changed over time, and you might be even, like in one era or the other, or might be stuck even and can't upgrade, or maybe you haven't started yet and can then realize, okay, that's not how we do it anymore, right? So that's kind of the idea of the first part of the talk, to look a little bit back in time, how things have been done and what are the issues with these approaches, yeah? And then once we have that, we're going to look at basically the current best practice, right? Which is this thing called backend for frontend pattern, and there are a couple of variations of that even already. And we're going to look at these two, and then at the end I'm going to show you how you could build your own, yeah? Because actually all the building blocks are there, you just need to put them together in the right order. Before we start, I want to set the scene, yeah? A couple of months ago, a blog post I've written in 2020 made it to Hacker News, okay? And I got basically shredded to pieces on Hacker News because apparently people only read the headline and not the second line. We said that was kind of a joke, yeah. But they said oh, this guy says spas are dead. He's so wrong, yeah. But what I was alluding to in this blog post is that there are browser changes already present and coming up that make it harder and harder to write a traditional SPA. Yeah? And what this really was a continuation of an older blog post I wrote in 2019, where I was researching an alternative way to secure SPAs. And by the way, whenever I say SPA, that also includes Blazor. Yeah, if you are here for the Blazor part, the rules are exactly the same. It's code running in your browser, just, it looks a little bit different. So, but the one good piece of feedback I got was that, there are so many different types of reasons why you want to write a browser-based application, and all I was talking about was how they are becoming less and less useful for the types of customers I have and the types of applications they are writing. Yeah? And that is, boring business applications, I guess, yeah? Business applications where the front end runs in the browser, you are having an authentication system you want to connect to for, single sign-on, federation, all of these things, and you want to call APIs from within that front end, typically using OAuth, right? So that's where I live, basically, and that's what I meant with spas are dead when it comes to this type of architecture, yeah? I totally agree that there are other types of spas out there which don't have these things, and they might not be affected by what I'm saying now. Or maybe they are. Good. So let's start with way back in time, right? You basically, let's say you had an ASP.NET Web Forms application or something like this, right? And at some point, the industry trend was this new thing called Ajax style, right? I can literally remember Microsoft demos on stage with the Ajax control toolkit, right? They pressed the button and said, look, no flickering. Isn't that great, yeah? It was great. They started shipping jQuery with the product, right? So that people can do their own no flickering web applications, yeah? And the nice part was, it just worked. Right? You just wrote a little bit of JavaScript, you called an API, and by the way browsers worked by the time, basically you use cookie-based authentication. The cookies were just flowing back to your backend. There was no extra code to write for the security. It just worked until cross-site request forgery was discovered. Yeah, and cross-site request forgery is basically a nice hack, right? So the idea is basically you have your browser, right? And think of the browser as an operating system running multiple applications. Some of them are trusted, some of them are not trusted, right? And you go to your trusted application, app.com, whatever. You log in. The browser sends you an authentication cookie. And from that point on, when your application makes AJAX calls or postbacks, the cookie just flows back to the server and all is good. Yeah? But now let's say you're opening another tab in the browser and you go to evil.com, right? And evil.com starts now making HTTP calls to your real application, right? And the way that browsers work is they say like, oh, I got a cookie from app.com and this application is making a call to app.com. Let's just send that cookie along, right? And what that essentially means is that the evil application can now make network calls to the other application impersonating the currently logged on user in the other tab. That's cross-site request forgery. Yeah? Amazon was, funnily enough, one of the first companies got hit by that. You remember the one-click buy button, where you basically had a link, you clicked the link, you bought a book, right? That used the fact that there was an existing cookie session going on in the browser. So if I would now bring up some website, have an image tag on the website, set the source to the one-click buy button link, you come to the website, you're logged onto Amazon, you buy my book, right? Fun. So I always have people in the room saying like, this can't be true. If that would be true, the whole web would be broken, and yeah, you're probably not wrong. So what I have here is a simple app, right? I'm logging into this app. Nothing special, right? I'm logged in, I just set the cookie, and then I'm doing work as Alice, yeah? And now I have another app here, which is called the evil app, yeah? And let's bring this up and see what it does. I mean, who could resist, right? Let's have a look what evil app is actually doing. You see here's my click here, and what it does is it basically does a cross-site post to another application, which is my app running in the other tab of the browser. And there's not even JavaScript necessary for that. I'm just making the user click a button. I'm contacting an endpoint on the other application. And of course, when I'm doing that, I'm doing work as Alice. Just evil work now. And you can imagine this post back could be automated with JavaScript, could be even in a hidden iframe, right? There are all kinds of things you could do here. That's cross-site request forgery. So how can we protect against this? This mitigation technique is pretty much known to everyone, and that the reason for that is because Microsoft put it pretty much into every template since they released MVC. It's called anti-forgery protection, right? And the idea is basically when you are rendering down your form, you are setting a special cookie called the anti-forgery cookie, and you're setting a hidden input field on the form, and the values of the two are the same, okay? And when the page posts back to the server. There's a filter running, the validate anti-forgery token filter, who then looks at the cookie, looks at the hidden field, and if they match, all is good, right? That was pretty much automatic, yeah? For API calls, this wasn't automatic because you're not doing postbacks, right? And I've done lots and lots of code reviews in my life where like they had the anti-forgery protection for the forms, but they didn't have it for the AJAX calls because it meant things doing like getting their verification token from the form, setting it on a header manually, posting it to the server, writing some custom code in the server, and so on. Yeah. So that's the CSRF problem. Yeah. And when we go to our controller here, right, our home controller, and I would put in the validate anti-forgery attribute here, and would run this again, and would go to evil app, I guess, it wouldn't work anymore. Right, so that was an easy fix. But as I said, it was only easy because it was built into ASP.NET. The AJAX call protection was never built into ASP.NET, and actually many people I spoke to didn't even know about this problem. Yeah? So that is real. Okay, so that's the cookie era. Yeah. With all of these problems, with these CSRF attacks and so on, and other ways how to exploit cookies, the IETF picked up the problem back in 2008, 9, something like this, and said like, okay, how about we get rid of cookies and we exchange them with tokens, with OAuth tokens, right? So instead of sending the cookie to the API endpoint, we're sending the token to the API endpoint. And the big difference is that the token does not get sent automatically. You have to do extra work for that, and the browser is not involved with this. So the CSRF problem goes away, right? So funny side story, if you go back to history in the IETF, you can read all of the communication. And when somebody in 2008 or so said, like, maybe we should introduce an OAuth flow for JavaScript applications, the first answer was, why would you ever write an application with JavaScript, right? So times have changed. So they said, okay, let's do this. But again, going back 10 years in time, they had to find a way to get a token from a server that purely and only involved browser redirects, because there was no cross-origin AJAX calls by the time that didn't work, right? So they made a lot of security compromises and came up with this thing called the implicit flow, okay? That one is deprecated by now for good. But the way the implicit flow worked is the browser makes a redirect to the token server, requests the token server sends the token back on the URL, right? Then the JavaScript has to store the token in the browser, and then it can start calling APIs. Yeah? Now, the issue with this approach was, transmitting secrets over a URL was never a good idea. Yeah, there are so many ways how you can leak that data, right? Log files, proxies, browser history, right? Or just plain implementation errors. And that's why this flow by now is heavily discouraged and soon will be removed from the OAuth stack altogether with the new revision with OAuth 2.1. Yeah? So now fast forwarding to 2020, whatever, they said like, okay, we have solved the cross-origin AJAX problem. We can now make AJAX calls to get the token, and we don't have to store it on the URL, right? So then the intermediary guidance was, don't use implicit flow anymore, don't use cookies anymore, use the authorization code flow in OAuth. Yeah? And the way the authorization code flow in OAuth works is that the browser makes a redirect to the authorization server, and then collects the so-called authorization code, which is just an artifact that is on its own not sensitive. And then the JavaScript makes an AJAX call to the token endpoint and retrieves the data, so to speak, on the back channel, right? Problem solved, right? The URL is clean now, all good. Let me show you an example that is using this style of code. It's the SPA. right? So basically what you did is you got a JavaScript library which does all of the coordination, going back and forth, right? And that's exactly what I'm doing here. I'm pulling in an OpenID Connect client JavaScript library. I'm configuring all my stuff, my authority, client ID, the authorization code response type, and so on, right? And then, if I run this, I can now control everything from JavaScript. Yeah, no more cookies, no more URLs are being harmed here. So I can press login, log into the server. And here I am. I have my identity, I have my identity token, I have my access token, and now I can start calling APIs. Yeah, like if I would press this button here, I would now be able to call an API directly from JavaScript with the access token. Great. Or maybe not. So the next challenge we have is, by virtue of that everything is now driven by JavaScript, we have to store these access tokens somewhere, right? And they are sensitive data. You don't want to lose them. You don't want to leak them. You don't want that somebody exfiltrates these tokens. And of course, because everything is running in JavaScript, you have to store the tokens in the browser, right? In memory, local storage, session storage, whatever, right? Somewhere. But all of these storage mechanisms are by definition accessible by JavaScript, right? And guess what? There's a new attack. Well, it wasn't really new, but now had a new importance, which is called cross-site scripting, or if you want to have a general term, code injection attacks, right? So if your application has a cross-site scripting vulnerability, an attacker could inject JavaScript code in your application, which would read the token from wherever you store it and send it along to a different application, right? The attacker's application. And this threat and vulnerabilities are far away from being solved in JavaScript, right? I mean, we are making progress with all kinds of complicated stuff we add on top, like content security policies, or is it called trusted types now in React, and so on and so forth. But still, if you look at the OWASP top 10, since ever, code injection is in the top 3. It's just going up and down between 1 and 3, wherever, you know. But it's there, right? And if you look at new research, you remember that there were these Spectre attacks where you can basically send weird packages to a server and then read arbitrary memory from the server. Guess what? They also apply to browsers. Yeah, so Google has found out that there are, even in Chrome, Spectre attacks where an attacker potentially, you know, can read RAM. And if that RAM is your access token, right? So long story short, I don't want to store my tokens in the browser. It's way too dangerous, okay? So, you know, go back to our app here. Here's my token, right? And if I look at session storage in this case, here are the tokens, right? And if I am now a clever attacker, I can write some JavaScript code, read them from session storage, and send them anywhere I want. You know? And then all of the other things, yeah, all of the little browser differences, like maybe, so for example, in Safari, in incognito mode, there is no session storage. So you can't use that, for example, yeah, and you have to come up with other ways of doing these things, yeah. So that's challenge number 1. Challenge number 2 is now, once you have that token, and let's just ignore for a second that the token is not really secure because it's in the browser, how do you manage the token, right? Tokens have a lifetime. When that lifetime is over, you want to get a new token. How do you, in your SPA front end, notice that the user has logged out and you want to, you know, like clean your data, delete the tokens, you know, session management, basically, yeah? There are lots of protocols and specs out there that solve these exact problems, yeah? So that, for example, you can open an invisible iframe and go back to the token server, get a new token, for example, yeah, or maybe or opening an iframe to the server, which sends you notifications when the user has logged out. But the common denominator was they were all based on iframes, hidden iframes, right? Because that's like our one trick in the toolbox that always works somehow, right? So yes, same thing here with this application, right? You see, when I want a new token, look at that. No flickering. Yeah, job done. So if I look at, sorry, no, not here, but inspect the page, inspect, you see when I'm pressing the renew button, you see that for a very, very short moment, there's an iframe going back to the token server, getting a new token. That was the official recommendation how to do this. Yeah? Also, you can see here, there's another iframe that points to the token server itself, to a special endpoint, so that the token server at logout time can send a notification back to the client that the session is over, so they can close the application, basically. Yeah. So when I now go to the token server here, right, and log out, magic. Okay, magic done with iframes. So that's how that worked. And we, for 7 years, maintained an officially certified JavaScript client library which implemented all of these features. And just recently, like 6 months ago, we decided to basically archive the project because you just can't win. Yeah? Regardless what you do, the tokens end up in the browser. We had so much trouble maintaining this library over different browsers, different browser versions even. It was always something. Yeah? And we decided, no, A, we don't want to buy into this approach anymore, and B, it's just too much work. Yeah? And now the next thing happens. The browsers are changing as well. Yeah, so all of the browser vendors have agreed that they have to do something about, tracking networks and advertisements and all of these things. And the different vendors approaching the problem in different ways. But basically, Google has announced a very big change. Actually, they wanted to make this change this year, but then they got problems with governments and things because they would break everything, basically. So they delayed it to 2023. If you want to Google for that, it's called the Chrome cookie apocalypse. Okay? But like most people said, yeah, as long as Chrome is okay, we are fine, right? All of these niche browsers like Safari and Brave, we don't care. But guess what? Safari has changed their behavior too, and Safari has a 20% market share, and you probably have customers using Safari, okay? So what Safari did as the first step is they now block cookies in iframes. Do you see a problem with all of our iframe-based approaches now? Right? If there's no cookie flowing anymore, I can't get a new token. If there's no cookie flowing anymore, the server thinks I'm locked out. Yeah? So when I run this exact same application that is working fine here in Chrome on Safari, okay, I log in. Yep. Why? Well, because the front end opened the iframe to receive the logout notifications. The cookie is blocked by Safari, so the token server says, there is no session, you are locked out. Okay? So you're immediately locked out, and guess what? The renew token doesn't work either because the cookie is blocked as well for the renew token requests. Yeah? So that's today already. And the two browsers which have implemented this by default now is Safari and Brave. In Firefox, you have like an enhanced security thing. If you click that, you get the same behavior. The only two browsers right now which do work is Chrome and Edge. Okay? So that's coming. And if your application is built on this approach, it will not work anymore in the future. So what does this all affect? Well, silent renew, as I just shown you, session notifications. Maybe you know what a front channel logout notification is, right? So when you log out, let's say from Azure AD, and then they send like logout messages to your applications in iframes, guess what? To tell them that the user is logged out, right? And again, since now these browsers are blocking the cookies in the iframe, especially cross-site, that is also not working anymore, right? So what did people end up doing to solve the problem? They said, like, okay, you know what? Let's just use refresh tokens in the browser, right? Refresh tokens give us a way to manage our token lifetime without these cookies, yeah? Which is the worst possible thing you can do from a security point of view, right? a JavaScript application or a browser-based application is by definition a so-called public client in OAuth, meaning they don't have a client secret. And now you have a refresh token in the browser as well. If somebody can steal that refresh token, they can, without even knowing your client secret, create new access tokens as long as they want, typically. Okay? You know, there are popular cloud management websites that use refresh tokens. You know, what could go wrong, right? Okay. So all of these things together brought us to the decision, this is not the way forward. Okay? And we don't know what other crazy things the browsers will do in the future, so relying on browser behavior here is not going to work. We rather want to probably play nice with the browsers, like use the security sandbox that they think is the right one, which these days is the same site policy. So if something comes from the same top-level domain, right, and the same origin policy, which means your code is running exactly on the same origin where the server is running on. These are the two security features of browsers. All of these iframes and the stuff was working around this, right? And now they're shutting it down. So, but there are also good browser changes. And that is basically what they call same-site cookies. Yeah? So the cross-site request forgery problem was enabled by the fact that the browser, when you make a network call, it only checked where is the call going to. Right? And if you had a cookie for app 1, somebody in that browser makes a call to app 1, the browser sent the cookie. Right? With same-site cookies, they do an additional check now, and that is who is actually sending the cookie. And only if the sender and the receiver match, they are on the same domain, same site, then they will send the cookie. And now you might ask yourself, why wasn't this like that from the start? We don't know, right? We'll live and learn, I guess. Right, so same-site cookies protect you from cross-site request forgery by default. Okay? And it's very important to understand what an origin is and what a site is, right? An origin is the exact triple of protocol, DNS name, and port number. That's an origin. A site basically is they call it TLD -1, which doesn't help really, but let's say you have mycompany.com, then mycompany is the site. So if you have app 1, mycompany.com, app 2, mycompany.com, app 3, and so on, then that is a site, and cookies can flow freely inside, but not outside. Okay? Sounds perfect, yeah? But only as long as you're not a victim to a subdomain takeover attack. Sounds scary, right? A subdomain takeover attack is that an attacker is able to execute code in your site. And how is that even possible, right? A couple of years ago, Electronic Arts was hit by that, right? And basically the way this worked is this, yeah? EA needed a new application. So some developer created an Azure website and wrote this application on that website, right? And then they added a custom domain to it. So basically, blah, 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 azurewebsites.net became billing.ea.com, right? Cool. So at some point, EA said, okay, we don't need this anymore. We merge this into the main application. They shut down the Azure website, but the DNS entry was still pointing to it. So now you can automate this attack by querying DNS servers and see, oh, look at that. It's a dangling pointer, if you like, to a non-existing Azure website. So let's just register the Azure website. The name is free now. Okay, and suddenly you can write code which runs on the site of the victim, right? Billing.ea.com was now an attacker website and not an EA website anymore. And then same-site cookies won't help you. Yeah, all I'm saying. Same-site cookies are a nice way of having a baseline security in the browser, but it's not the silver bullet. Yeah? Okay. So, now, fast forwarding. Browsers on one hand get more restricted, on the other hand have better security like same-site cookies. There are new IETF recommendations. Again, one is the thing called OAuth for browser-based applications. It's not a protocol, it's what they call a BCP, a best current practice. And it's a guidance document, if you like, which everyone should read, in my opinion, that is building browser-based applications and is using OAuth. Yeah? And OAuth was a protocol designed for doing cross-site API calls, right? And funnily enough, in this spec or in this document called OAuth for browser-based applications, one of the guidance was, if you don't call cross-site APIs, maybe you don't need OAuth, which is actually very true. Okay? Which was funny for an OAuth working group document, to be honest. Yeah, it's gone by now, but you can, if you think reading RFCs is geeky, even geekier is reading the diffs between different versions of RFCs. And you can find this sentence if you go back in time because they basically have version control on it. Yeah, so yeah, that's true. Yeah, and at the same time, there's another document now popping up which is talking about this BFF thing. Okay, so BFF stands for backend for frontend, and that's basically what we're going to talk about next. Yeah. So the fundamental thing here is that you have to realize that there are two types of JavaScript applications or Blazor applications, whatever you want to call them: the ones with a backend and the ones without a backend. Yeah. So the ones without a backend, they are exactly what I just shown you. Everything is running in JavaScript. You're doing the token management in JavaScript. You're calling the APIs in JavaScript, and you have all the problems I just shown you. Yeah? But wasn't that the dream of the SPA people, right? Oh, it's just HTML, CSS, and JavaScript, and it's like a real program. Yeah? Well, it isn't. And the BCP says this is okay for low value applications. Well, like when you're not dealing with sensitive data, so to speak, right? This pipe dream of I just put my stuff on a CDN, it's just going to run in the browser, it's all good. Yeah. If you're dealing with sensitive data, you don't want to store the sensitive data in the browser. Full stop. Yeah. And the only way you can work around this is by adding a backend to your application that stores the sensitive data. Okay. So the idea with the BFF approaches is that the JavaScript itself does not do any security. Yeah, it just does what it does best, to be honest, is UI, right? And all of the authentication handshakes, token storage, token management, calling APIs is happening on a dedicated application backend, right? That's where BFF comes from, backend for frontend, and maybe also because they are so tightly coupled, they hopefully are best friends forever. Yeah. That's the idea. Yeah. Now, this new IETF document makes it more complicated, I think, than it should be. They are distinguishing between two flavors of BFF. One is called the full BFF, and one is called the TMI BFF. And that's an attempt from the IETF to try to be funny. TMI stands for too much information. Yeah. Yeah, I'm still laughing. Basically, the idea is this. The full BFF does all of the security stuff on the server, right? And even calling the APIs is happening server to server. Whereas the TMI BFF has this, half-baked would be maybe the wrong word, but in the middle approach, where it says, okay, we do all of the token management on the server, but then when you need to call an API, we send the token down to the browser to call the API. And they also say the full BFF approach offers better security, right? Because you only solved half of the problems here. Yeah, the token will still end up in the browser and can be stolen. So that's, IETF ASCII art. That's how that looks like. So the idea is, right, the front end wants the token, goes to the back end gets the token from the token server, and then sends the token down to the front end, and then the front end can call the APIs directly. That's the TMI BFF. I'm not going to talk about this because I think this is only half useful. The one I much more prefer is the full BFF approach, where everything is happening on the server. The tokens never leave the server. The JavaScript will never do cross-site communication on its own. But with the one downside, of course, is that all of the API calls need to go via the server, so they're getting proxied, right? Which might be a concern or not. So, now that we know what a BFF is, let's build one, or have a look how one could look like built with ASP.NET Core. And the nice thing is that basically all of the building blocks are there, right? So you basically need a server-side ASP.NET Core application. You plug in an OpenID Connect and OAuth client library, and we have really good ones in ASP.NET. Yeah, the OIDC authentication handler is probably the best client library I've ever seen for web-based applications. We plug in some session management, right, so that we can deal with the cookies going back and forth between the backend and the front end. Again, the ASP.NET Core session management library is really good. Yeah. And then we plug in some token management so that, you know, all of the getting the token, refreshing the token, getting a new token when the old one has expired thing. That part is not built inside of ASP.NET Core, but there's a library that can help you with that. And then you have to deal with your API endpoints, and then ultimately you have the UI assets. Yeah? So just to reiterate before we move on, yeah? The idea is this. You go to the application, you start it, you go to an application server. The application server serves the static assets down to your browser. Whenever you want to start the authentication handshake, you're calling an endpoint in your application server, which then in turn starts the handshake. The tokens coming back from the authentication handshake will be stored on the server. Yeah? The server will create a session for you, which is cookie-based, same-side cookies and all the bells and whistles that we can do to make it secure as possible, and even something more, which I'll show you in a second. And then from that point on, the communication between front-end and back-end is always being secured via this session cookie. Yeah? And whenever the browser or the front-end needs to make a call to something that is not living in its back-end, the back-end is proxying it to the remote location, attaching the access token, and sending the response back to the browser, right? And that might sound a little bit, you know, that sounds pretty old school. But yeah, from a security point of view, that's the only way to do it, in my opinion. So, as I said, that's that. Full disclosure, I've built such a framework before. It's part of Identity Server, but that's not the point. I want to show you what we did, basically. And the building blocks, as I said, besides token management, are all part of ASP.NET Core. So first of all, we need a way to serve our static content, right? That is the static files middleware in ASP.NET Core. That's the thing that serves down your JavaScript, your HTML, your CSS, and whatever else you need, right? We need authentication. That's the ASP.NET Core OpenID Connect handler. And then we need to think about how to secure the communication between the front end and the back end. And let's start with the authentication. As I said, that's just the standard OpenID Connect handler. You see, on the server side, you point it to your trusted server. The nice thing now is that, you know, by definition, a SPA running in the browser doing JavaScript is always a public client. It cannot have a secret. By moving that logic to the server, you turn it into a confidential client, which does have a secret and can authenticate with the token server, right? Which is great. And then basically all you need to do is expose some local endpoints in your backend to be able to trigger the login and logout functionality of your server, right? So let's do this first. Let's go to the JavaScript sample here. So for all of you who are doing, you know, standard ASP.NET Core, this looks pretty familiar. Here's our startup file, right? We're adding authentication here. We are setting our cookie. We can use the strictest same-side modes of all because we are not, you know, so for those who don't know, there are 3 modes for same-side. One is called, well, none, which means you don't have protection. One is called lax, which means only post requests block the cookie cross-site boundaries. And strict means even GET requests are getting blocked, the cookies are getting blocked across site boundary. Now, which one to choose here? Well, lax, always lax. Strict might be not compatible with your application because let's say you have a link going to another application. That simple link will not transfer cookies over, so that might not work for you. But as we all know, we don't change system state based on GET requests, so lax would be good enough, so the post requests don't get cookies anymore across site boundaries. Then here's my OpenID Connect handler. Oh, and by the way, that's another nice thing here. It's not really an official standard, but all browsers understand it. If you do a __ host prefix on the cookie, you prevent subdomains to override that cookie, which is another attack that, by the way, is possible in browsers. That's why many years ago, you remember that github.com had the user pages also on github.com? And that there was an attack found by a very clever guy who found out that if you are you can override in a subdomain the cookie of the main domain. It was kind of fun. And that's when GitHub moved github.com as its own web asset, and then the user pages are now on GitHub.io. Right? So just get a different domain name that this cookie thing cannot happen anymore, and this __ host thing prevents this as well. Okay. Yeah, and then we just ask for API access here, ask for a refresh token so we can do token management, and that's pretty much it. Yeah. So let's run this. Okay. Everybody needs a to-do application. So you see, when now that the SPA wants to trigger the actually pretty complicated OpenID Connect authentication workflow with all its bells and whistles and front-end, back-end channel communication and so on, all it needs to do is, you see, go to the local endpoint called login. That's all the front-end needs to know about, right? Log in. I log in. And I'm logged in. Okay? And logout is the same story, right? We just trigger /logout on the back end, and then the whole thing will be reversed. That's nice. Compared to the actually, I'm kidding you not, thousands of lines of code we had in our OpenID Connect client JavaScript library. Yeah. Right. So now we have a session with the server. Okay. So now we're gonna secure this session with this cookie handler I just showed you, use the same site mode, use the host prefix, and so on. So now we basically have sandboxed our communication to the same site. Okay? And now, your JavaScript client might want to know who is the user, or maybe there are claims about that user that they care about, right? So the next thing you only have to do is expose another endpoint, let's call it user, right? Which then sends the contents of the session as JSON back to the client. Okay? So let's do that as well. Show session information, and you can see, apparently, security is much easier for me than UI. I don't care about UIs, But basically, that is the server-side session, right? And there's a way to send this down to the client, maybe because the client wants to know the name of the user, right? Or maybe they need to know, I don't know, his favorite color or whatever, right? You could even use this, periodically to query the server-side session state, like is the user still logged in, for example, yeah, if you want to do something like this. And quite nice, actually, starting with .NET 6. When we wrote this, yeah, and thought about, like, does it make sense to poll the server, let's say, every minute to ask, let's say you want to implement an inactivity counter, something like this, right? So imagine now you would ping the server every 1 minute, but the server is configured for sliding expiration cookies. You would extend the session time every time you're doing the ping, right? So we opened an issue with Microsoft, and hey, it's the new Microsoft, they fixed it. So now, starting with .NET 6, there's a way that you can dynamically suppress sliding cookies. Okay, so imagine now you have this user endpoint, you put in like a special query string parameter, slide false. You can handle an event on the cookie handler, and if you see that query string, you say, don't slide the cookie. And that means, after some time, the session will be expired, and that's exactly what we want, right? Okay, cool. What else do we have? Token management. So that's the only part where ASP.NET Core does not help you. That's a long-standing discussion with Microsoft, but basically, it's not implemented. Yeah? And what token management means is, of course, that now that the server is keeping the tokens and doing the API calls, right, you have to make sure that your token is still valid. Yeah? So after a certain amount of time, the token will be expired. Then there's the refresh token that you can use to get a new token, right? and so on. Actually, maybe I can quickly show you that as well. We have some time. There's a sample here. I might need to shut down the other client. MVC. So yeah, let me just show you that, and then I'll show you how it works. So when I log in here, right, you see that inside the session, so that's pretty much poking into the session of ASP.NET Core on the server side. What's in there? You see in ASP.NET Core, they store the access token in the session, they store the refresh token in the session, and they also have something called expires at. And with these three values, you can imagine, right, you can write some automated logic saying like, okay, I know when the token expires. Now I want to use it. It's expired. Here's the refresh token. Let's under the covers get a new access token, get rid of the old access token, store the new one in the session, and all runs smoothly without you having to pollute your business logic with that token management code. Okay. I don't have to run this because it's actually pretty boring to look at expiration times, yeah, and see, oh, a new token, yeah. But the way this is wired up, and that's just pure magic, yeah. I mean, the ASP.NET Core system is so extensible. So basically, all of that what I just described is by using one line of code. Okay, and this is basically wiring up all kinds of stuff in the background to monitor the session, monitor the expires at thing, and then all you have to do is say like, hey, HTTP client factory, register a client that is wired up to the automatic token management. So whenever I'm using this client now from the factory, it will under the covers automatically do token management for me, right? And actually, if we look at the code to do that, it's super simple, right? All you need to do is say, hey, client factory, give me a client, and then do an API call. So you don't care anymore with token expiration, attaching the token, refreshing the token, and so on and so forth. Yeah? So that's nice. That's a library written by me that is free. Just plug it into your application, and should work. Okay. So coming back to this guy. Oh, I'm still logged in. No. Let's see. Log out. Okay. Log in again. Cool. So, what else is missing? Oh yeah. Now this is a tricky one. Session change notifications, right? So as I said, the old session state, a session change notification mechanism using iframes doesn't work anymore. Yeah. So there are really only two ways of doing this now. The one I just mentioned by probably polling your backend periodically and say like, is he still logged in? Is he still logged in? Or by sending some sort of event down from the server to the client, right? But the first problem you have to solve is how does your backend know that the user has logged out from the token server, right? Again, front channel notifications rely on iframes. They don't work anymore. There's another standard here called back channel notifications that you can use, and modern identity systems support that. And the idea is basically, instead of relying on the browser to send you a notification, basically the token server sends a server-to-server call to the backend saying, hey, Dominic has logged out. Okay? And when then the server sees that event or that notification coming in, they can delete the session server side, which then triggers a notification on the client side, and that gives you the logout behavior, so to speak. Okay? Yeah, and you can implement this endpoint. Yeah, and that's another thing missing in ASP.NET Core right now, at least. But this will come, right? Because Microsoft's premier identity product, Azure AD, runs by definition always cross-site to your company website, right? So the front channel stuff will not work anymore, so they have to implement this sooner or later. Cool. So last thing I want to talk about is now we want to call APIs, okay? So when we work with our customers to refactor their spas to this new style, we often found out that there are fundamentally two types of APIs they have. One type of API is which are just exclusive for the front end. No one else is calling them besides the front end. Okay? And if you find those APIs, then you can just put them in the backend, right? What's the point of making complicated cross-server calls whatsoever? Just put them in the backend, and you can secure them with the session. Yeah. The other type of API that you probably find are shared APIs, where you see like multiple people are calling this. Yeah, multiple clients are sharing that API. And in that case, well, you should make it shareable by putting it on a dedicated endpoint and then use the proxy technique, so to speak, to call them. Okay? So another nice trick that I learned while building this framework is, so let's say, we have same-site cookies. They are great. They are free, right, because they are implemented by the browser, but they only secure us against attacks across site. Yeah? So what if we have this attack scenario where someone runs on the same site, and I didn't find this out. There's a very smart guy that I know who told me this trick called Philippe. All you have to do to protect your API calls even tighter than same site is just by putting in a custom header on the API call. It doesn't really matter what header it is. You can call it foo and bar. It doesn't matter, right? We call it XCSRF, and the value is static. It's a 1. Yeah? And that looks totally strange, right? Knowing all of the complicated stuff Microsoft is doing with anti-forgery tokens and so on. But it turns out, since we are now requiring a cookie to call the local API endpoint, meaning you make an AJAX call and you have to say with credentials, right? And if you are in addition adding a custom header to the AJAX call, the browser will always kick off a CORS pre-flight request. Okay, so CORS is this thing which tries to negotiate, can we call APIs cross-site? So it will always kick this off because you are violating the rules. You are sending a cookie and you're sending a custom header. It doesn't really matter what the header is, but that's it. And CORS has 2 types of checks. The one CORS check is, let's just do the call, and on the way back, we check the CORS policy, and if it doesn't fulfill the policy, we just don't pass the data back to the JavaScript. Yeah? And the other one is called the pre-flight request, where CORS first asks the server, are you okay with calling you? And if the server says no, then it will not call the server. What's the big difference here as well? Think about Spectre attacks again. Yeah? With the first approach, the data is in the RAM of the browser. With the second approach, the data will never arrive at the browser. Okay? So that's cool. I mean, I was blown away when I learned about this. Yeah? Right, and basically all you have to do is put in a little bit of middleware in your pipeline that checks every API call has this header set. Job done. Okay? That's what we do basically here. Here. That's the middleware that is basically checking for this static XCSRF header. And if it's not present, it will reject the call. Yeah? And then you can actually mark the endpoints in your application that these endpoints want this extra security check. Right? You might have other endpoints which don't want this. Maybe we want to intentionally allow the cross-origin scenario, but if you mark it like this, then all endpoints here, in this case MVC endpoints, are secured by the extra check. Right. And if I now run the front end, right, I can, you see, create to-dos, and that is calling a local API endpoint, right? Just to prove I'm not cheating, that is actually working. Okay? Good. And the last thing is remote APIs. So if you need to call APIs which live on a different server, well, then with this pattern, you need to proxy the calls. Okay? How you proxy them is totally up to you. There are fundamentally, I guess, 3 things you could do. One is create a local API endpoint that gives you, that takes the local call and then turns around and makes another API call to the other server, right? That is maybe good for smaller API services. If you realize you have to replicate a whole remote API in the local thing, that might not be what you want, right? Then you could employ some sort of reverse proxy technique, yeah? There's actually a nice reverse proxy now for ASP.NET Core called YARP. It's a weird name. It stands for yet another reverse proxy. And think of it as an in-app reverse proxy. Yeah? It integrates into your ASP.NET host. And you basically can say, when you get a call on this endpoint, just transparently proxy the call to the other endpoint, right? And that's what we used. And the way this looks like is now, basically you go to your endpoint mappings, you say, okay, whenever you get a call on API in the local application, which is secured by the session and blah, 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 right? Turn around, go to this other API, and by the way, while doing that, attach the current access token of the user. So from an API point of view, it looks like as if the front end would have called the API directly. Okay? So just to show you that, so here's my to-do controller, right? So let's just don't use this anymore. Go here and enable the reverse proxy. So run my front-end host again. And run the backend host, which now has the shared to-do controller. Yeah, backend API host. And then in the browser, I create something, and it just continues working without having to change the front end at all. Right? It's transparent for the front end. Good. So that's pretty much our conclusion how to solve this problem. Yeah? After having all of these painful years of doing this, and this stopped working, then doing this, and this stopped working, and this had this problem, and so on. So, as I said, from a security point of view, that is the recommended technique. And we have more and more customers where there's just a statement, all new SPAs must not have tokens stored locally in the browser. That's the requirement from a security point of view. And that's the only way how you can actually solve this, that I know about. Good. So we have 3 more minutes. Any questions? Really?
Basically saying now is that if you have any security considerations at all, don't build serverless applications.
I don't know. Serverless is such a buzzword.
Yeah, it is.
I'm not sure if that clashes, right? So the way I understand serverless is it's a hosting model, right? But you're ultimately still running some sort of host on the back end, and if that host has all the features that you need to manage sessions and manage tokens, totally fine, right? All I'm saying is, if you mean serverless with there is no server, then this is the wrong approach, okay? Any other questions? Yeah, loud. Louder.
You said in .NET 6 you have a new function for preventing the session from sliding.
Yes.
I was wondering if you had an implementation for that showed that
So the way this works is basically you do here that there's a new event called options.events.something with sliding, on check sliding expiration. Okay, so you implement this event, and then you look, for example, for a special query string coming in, and when you see that query string, you return some true or false or whatever, right? And then they don't slide the cookie. Yeah? Anything else? Another question? Yeah?
Promise not to drop.
Huh?
There are a couple of new OAuth specifications, neutral TLS, default. And I'm just thinking, if you implement one of them, wouldn't TMI BFF pattern be viable? I'm not saying you want to use it.
So first, okay. So the question is with depop and MTLS, which probably sounds like Greek words to most people here, but is it viable? So first of all, MTLS you can't use in the browser. Yeah, it's not designed for browsers. Depop, I don't think so, because still with Depop, the secret, the key must be available to the caller. And again, where do you store the key now? It will again end up in JavaScript somehow, right? But I agree with you that what I see as a win is that with this approach, on the server side, you can easily do MTLS. Yeah, you can easily do Depop, right? All of these extra security standards that pop up, they are pretty. I mean, MTLS was designed for server-to-server communication, right? And it's probably the most secure we have right now. And Depop is possible in the browser, but everyone is well aware that this will not solve the cross-site scripting problem, right? So yeah, you can make it harder, right? And but in security, you always assume a motivated and skilled hacker, right? And they will find out how that works. Yeah, when you can inject JavaScript, you can inject arbitrary complex JavaScript. You can install event handlers, right? I mean, all kinds of stuff you can do in JavaScript. Yeah. So, yeah.
You said that you add the course headers, making it all back to yourself. But if you're remoting, if you're proxying calls, is there any advantage by also adding course headers on the remote?
So you're saying I'm adding the course headers on the front end? Actually, I'm not. That's the trick here. I'm not adding the course headers, right? By omitting the course headers, I locked it down to same origin, right? And that's only relevant for browser to backend calls, and then on the server, no one cares about course, right? Yeah.
You skipped one of the slides that talked about licensing for your BFF library.
Yeah.
Was that on purpose?
It's not important.
It's really useful. It's great.
Okay.
And of course,
So
the licenses, you have to be a customer to them.
the license is what we call the fair trade policy. Is if your company makes less than 1 million, it's free. If they make more than 1 million in a year, you can afford it. Yeah. Which I think is the way forward for open source. Okay, thanks for your time. Enjoy the rest of the day.